Okay, algebra, so let's take you through a couple examples here that are going to help us better understand linear modeling. So let's look at this first one, and again, we should be comfortable with the fact that rate of change is our slope and that our starting value is our y-intercept. So here you go, the cost C of dollars of running a particular factory produces W widgets can be modeled as C of W equals 1.25 W plus 275. Let me start with the parts over here. What is 125 and what is 2175? Well, 125 or 1.25 is our slope, first and foremost. All right, but I'm going to say that as cost per widget. That should be pretty straightforward. And then the initial value, the starting value, I don't know, how about 2175 is our y-intercept, obviously, or our starting, or maybe start up cost. All right, so now let's answer the first part. What does C of 100 equals 2300 mean? I read that as the cost to produce 100 widgets is $2,300. Right? And that's just really reading and understanding what these equations are modeling. All right? Working with that, let's move on to exercise number 4. If we have water draining out of a bathtub, volume left, G gallons, is based on the minutes M that it's been draining for. Let's do average rate of change, or slope, from 0 to 2. Well, we increased 2 minutes. We decreased by, what was that, 38 gallons. So we lost 38 gallons in 2 minutes. Those are my proper units. So that's going to equal losing 17 gallons per minute. All right, let's swap this over and take a look at 2 to 4. Still a 2-minute interval, but it went from 28 down to 12. So now we lost 16 gallons in 2 minutes, and that's going to be losing 8 gallons per minute. Great question here, which we haven't seen lately. How can we understand that the relationship is not linear? Why is it not linear? Well, the big word with linear is constant. We need a constant rate of change. And right now, it's not constant. At first, it was losing 17 gallons per minute, and now it's only losing 8 gallons per minute. So it's not constant, which means it's not linear. All right, moving on. Let's do a little bit of work setting one up. Here's that solar question that I thought would be so interesting to some of you. They built up an excess of 6,500 kilowatt hours, kWh. When the heat's turned on, he begins to use at a rate of 50 kilowatt hours per day. If E is the excess, and D is days, let's write the equation. Well, we know that at the start we had 6,500, and we're losing 50 per day. So I like to write this equation like this. The excess after D days is going to equal what I started at, 6,500, minus 50 every day. Boom. How much of the excess will be left after 1 month? Well, we can just use our calculators and plug in 30 for days. And I'll let you guys work that out on your own. But it would be 6,500 minus 50 times 30. All right? And then if the heat will need to be turned on for 5 months, will the excess be enough to last this period? Little unit conversion. You want to figure out 5 months is how many days, maybe take a nice average number like 30, should get like 150 days, and then you can plug that in, and if your answer is greater than 0, you're good. Okay? If not, we're going to need to find a little bit more room than what's there in that excess. Okay, last question you had. Evan driving a car. After 1 hour, the tank has 7.5 gallons. Okay, and separate measurement here, after 4 hours, it has 3.5 gallons. We should have this as 1 hour. Let me switch back. 1 hour, we have 7.25 gallons, versus after 4 hours, we only have 3.5 gallons. So we should definitely recognize that it's going down. All right, so for the slope or rate here, well, we went up 3 hours. We used the car for 3 hours, but we went down. Let's see, how much did we go down? 3.75. All right, so we are using 3.75 gallons in 3 hours. And you can use that to get a nice decimal calculation of your gallons per hour number. 3.75 divided by 3 gets you 1.25 gallons per hour. All right, assuming it's linear, find an equation. Well, we would know this. The gallons per hour is going to be losing 1.25 for every hour that we use. Right, that was negative, sorry. All right, plus some starting value b, and then we could plug in to figure this all out, either one of our two pieces of information. So I'm going to go with 4 and 3.5. So 3.5 for 4 hours. What's that starting value? This gives me 3.5 equals -5 plus something. Add the 5 over. And I find a starting value of 8.5. And now I have the awesomest equation I could get for this problem. There's going to be gallons left after h hours. We're going to start with 8.5 gallons, and we're going to lose 1.25 every hour. And according to this equation, how many hours of driving would Evan run out of gas? You can just plug a 0 in here for gallons, and I will let you finish solving this one on your own. So thanks so much for watching, guys. I hope that this helps you have a better understanding of linear modeling.